Hi class, today we're going to work on the law of cosines. Our objective is to be able to use the law of cosines to find the side lengths and angle measures of a given triangle. We will be using the Heron's formula as well, or Heron's formula, to find the area of a triangle if and when you're only given the three side lengths. So in the past, when we worked on the law of sines, right, you'll learn how to solve triangles. However, because the law of sines cannot be used to solve triangles, which only have the side angle side or side information, we use the law of cosines instead. But eventually, we lead up to using the law of sines as well. So let's get you started on that one, okay? All right, so the law of cosines for a triangle, and you're given, of course, the different angle measures, you will be provided the three equations right here. So because we are using the law of cosines, we are using the cosine function. For example, lowercase a, b, and c over here on this triangle will be the side lengths. And uppercase a, b, and c will represent your angle measures. So for example, if you'd like to look for the side length A, okay, like the first equation, we plug in the two side lengths, okay, and then we plug in the angle measure for A as well, once we know that. And of course, you find the square root to find the actual length of side A. Okay, so it doesn't matter at this point which equation you used. What matters is that you're solving for a side length and isolating the variable, making sure you get the square root before you finish the problem. Or if you're solving for an angle measure, you want to make sure that you use the inverse function for cosine. All right, so let's try the first example out. Use the given measurement to solve triangle A, B, and C and round to the nearest tenth. All right, so let's start with your checklist. So in the past, we made sure we knew exactly what we needed. In this case, we need the measure of angle A, the measure of angle C. Okay, we're listing down the information that we need because that's what it means to solve for the triangle, to find all the other unknown parts. Okay, so now that we've listed down your three missing or unknown values, we're going to start by finding the third side here, okay? Why not start finding the other two angles? Well, at this point, I only have one angle measure. And because I'm using the law of cosines, okay, it would be very, very efficient for me to instead look for the third side. So let's write that down. Find B, the third side, okay? All right, so let's go ahead and plug it in. We'll assign A as A, B, and C correspondingly. So because we are looking for B, we are going to use the second formula down here. All right, so let's plug that in. B is unknown, okay, but we do know side A and side C. So all we're really doing is we're plugging in all the information that we have, where the cosine angle would be for 100 degrees, like so. And of course, now that you have the following, okay, so you're going to go ahead and simplify this, where b squared will remain as the unknown. And then you can simplify this whole expression. Now, you want to make sure you enter this into your calculator as a complete expression. So let me go ahead and show that to you right now. So let's open this up. So in your calculator, okay, whatever that may look like, okay, so let's key in the values that we found. So we have 7 squared. Okay, so notice how I'm going to type the entire equation in. So 7 squared plus 5 squared minus 2 multiplied by 7 and 5. And of course, cosine of 100 degrees, like so. Okay, so again, be very careful with the parentheses. If you miss one or if you add one too many, then it will give you an error. Okay, so again, making sure that your mode is set to degrees, like so. Okay, all right. So we're ready to evaluate. We hit enter, and so we get that, well, b squared, not b yet, b squared is about 86.2, all right, 86.2. Or you can use this entire value right here, so you don't need to do any rounding. So here's what you can do. Of course, you get the square root, you go to the second function and select the square root option, and then go up, make sure it's highlighted, the previous answer is highlighted, hit enter, and then this will allow you to use the actual value instead of rounding, which we're trying to avoid until we reach the end of the problem. So we say that, okay, actual side B measures 9.3 units. All right, so let's go back to the whiteboard right here. Let's write it down. So I think we mentioned that it was about 86.16 over here, but we had to find the square root. Again, if you can avoid rounding, that would be great. Otherwise, make sure you show me this value so I can confirm if we agree with the previous value before you actually rounded it. Okay, so we say it's about 9.3. So we found side B. That's the length of side B. I think it's fairly reasonable seeing that it's the side accused the obtuse measurement. Okay, so now we can go ahead and look for the other two unknown values, the measure of angle A and angle B or C. Now it doesn't matter which of these two you find first. It just so happens we needed to find this third side immediately. Okay, that's the most efficient way we can solve for the triangle. So let's start by identifying the measure of angle A. All right, so to find the measure of angle A, as I mentioned in the previous slide, we are also going to incorporate the law of sines. So to find the measure of angle A, let's go ahead and use the law of sines and create the proportion that we should be using. So angle A, sine A, unknown, over the side, which is 7. And of course, we set it equal to another ratio with the complete information. So in this case, that would be angle B, side B, as well, which we just found as 9.3. And you can go ahead and complete the setup if you prefer. Then it would just say sine C, unknown angle measure, over the side length. Okay. But for now, our focus is to solve for angle A. So between the two fractions, we're going to cross multiply. So we'll get 9.3 sine of A, which is equal to 7 multiplied by sine of 100 degrees. And again, you ask yourself, what am I solving for? Okay, I'm solving for A, so let me isolate that by first dividing by 9.3, all right? And when you do, you're going to get sine A equal to 7 multiplied by sine 100, okay, again, 100 degrees right there, over 9.3. However, considering that you're actually looking for an angle measure, right, it's an angle measure, you can't just simply look for the sine of A. So instead, this is where we start using the inverse function. So we say to find the measure of angle A, okay, that's what we were looking for. We're going to use the inverse of sine, like so, inverse, okay, and then we're going to plug in the information we have, okay. Again, we're using the inverse because at this point, we're looking for an angle measure. So let's go back to your calculator and enter this information so I can show you step by step. All right, so right here, let's start by using the inverse function. So you go to the second function and make sure you select inverse. Again, my calculator has been set so that it is in the degree mode. And we're going to go ahead and plug in the information we have. We have sine, or 7 multiplied by sine of 100, all right, over 9.3. So let's plug that in and we're ready to evaluate. Hit enter. All right, so this is right now, because you use the inverse function, this is the actual angle measurement. Let's round to the nearest tenth. This will become 47.8 degrees. All right, let's go back to your whiteboard and let's write this down. All right, so angle A is 47.8 degrees, like so. All right, so at this point, we've found the side length B, checked it off. We also found the measure of angle A, 47.8. And now we're down to finding the last missing part of the triangle, which is the measure for angle C. And as you know, the sum of all the angles in a triangle is going to be 180 degrees. So we simply need to take away the given measurements, the two given measurements, so that we can find the last missing piece. And then once you do that, okay, so the measure of angle C will result in a 32.2 degree measurement. And so this is how you can continue using the law of cosines. You start by identifying what you have, all right, and what you need to find, the three things we listed earlier. So we started looking for the third side length because that makes it more convenient and efficient for us to find the last piece of the side lengths. And then we proceeded, of course, to use the law of sines to help us to find the angle measure, okay, or one of the angle measures. And then, of course, now that we have that information, we simply took it away, the two angle values from 180 degrees, and found the last missing piece. Okay, so this is just one way you can use the law of cosines. Let me go on ahead and show you the next example. All right, so considering that we worked on a problem which is for side angle side, because it is a side and an angle between the other side that's been given, now we're going to look at an example where you have three side lengths given to you. Okay, so in the same manner, we're going to solve the triangle and round to the nearest tenth. Again, we're solving, so we're going to have to locate or identify what information we need to find. At this point, you need to find the measure of angles A, B, and C. All right, since all your side lengths have been given. So we can go ahead and get started on this, remembering that we're using the law of cosines. All right, so the only difference is that when you're working, okay, when you're working on a triangle with three given side lengths, you always want to start by finding the largest angle measure. Find the largest angle measure, okay? What this does is it ensures that we are actually following a very straightforward pattern, okay? So we start by looking for the largest angle measure. How do you know which one that is? Okay, look at the side lengths that you were given. The largest angle measure is whatever is across the longest side. So in this case, the largest or the longest side would be 12, and that's right across angle C. So we say we're actually looking for angle C right now. We're going to start by identifying that. And we can do this by using the law of cosines. So because I'm using C, I'm referring back to the equations that were listed, the three equations. Okay, so we're going to look at this. We're looking for side or angle C. Okay, so the most reasonable one to look for angle C among these three is to use the very last one. Okay, why use the very last one? Aren't we solving for angle C right here? So you're specifically looking for the inverse cosine of C. And that would be the most convenient for us to identify since the others only refer to angles A and B, and the lowercase refers to the side lengths. So we're going to go ahead and use the very bottom equation. So let's write it down here. C squared is equal to A squared plus B squared minus twice of A and B multiplied by the cosine of C. All right, so we're going to plug in the information we have. Right now, we're going to go ahead and do that, 12 squared. And then you have 10.5 squared plus 6.3 squared. So notice how we're just plugging in the angle or the side lengths that we already have that were given to us. Okay, we're plugging in. And of course, the very last part, we don't know C. So we're going to attempt and find that shortly. Okay, so you can go ahead and take a look at this example right now, this equation we are on. Because you're looking for cosine C, your objective is to isolate this part of the equation. At this point, you have to do a couple things, such as eliminating 10.5 squared and 6.3 squared. Okay, but also, notice how a few other values are being multiplied by cosine C. So we need to eliminate those as well. So let's do this step by step. So first we should subtract what can be subtracted from the right-hand side. So I'll go ahead and transfer, okay, all the other terms that I can move, such as the 10.5 squared and 6.3, like so. Notice how I changed the sign, so please make sure you do that. And then we can leave -2 and the rest of the expression that needs to be multiplied for now, like so. Okay, 6.3 cosine C. Okay, so again, our objective is to isolate cosine C right here. But in order for that to happen, okay, you have a couple of choices when you take this step now. Some of you will simplify this part of the equation, the left-hand side, and then of course simplify the first 3 terms by multiplying them already. Okay, so we can take that step. So I found that if I simplify just the left-hand side, this will result in -5.94, and that's exact. There was no rounding involved right here. And when we did multiply the other side this time, right? So when you multiplied -2 by 10.5 and 6.3, just those 3 values together, it results in -132.3. And then of course your cosine C is still there. Alright, which means we do need to solve for C. Now it's easier for us to isolate this part of the expression because now we can divide the entire thing by -132.3 like so. So really, okay, so let's write it up here. To solve for cosine C, we need to divide -5.94 by -132.3. However, okay, remembering that you're not really solving for side C. Instead, you're looking for the measure of angle C here, which means we need to use the inverse function. So to find the measure of angle C, we will use the inverse function for -5.94 over -132.3. Okay, and we will enter this into our calculator and evaluate. All right, let's try that out right now. Okay, so calculator. Okay, so we're going to use the inverse cosine. So second function and then inverse cosine. Let's create a fraction. Again, for those of you who are not able to use a fraction in your calculator, it's okay. You may just need to make sure you keep using a couple of parentheses. Okay, so -5.94 over -132. Okay, let's go back. It was 132.3. Okay, so 132.3, and then we will evaluate this. Again, we're looking for an angle measure, and we're rounding to the nearest tenth. So we say this is 87.4 degrees. All right, so we say, well, you know what? Angle C is actually 87.4 degrees right here. All right, so we found one of the angle measures, the largest of them 3. Now, on the next step, it doesn't really matter which other angle you find, as long as you started by identifying the largest one first. Okay, so if you want to go in a chronological order, we can go ahead and find the measure of angle A. So let's write it down here. So find the measure of angle A. And to find the measure of angle A, you can go ahead and use your law of cosines. So let's go ahead and do this right now. Because we're looking for the measure of angle A, let's go back to the equation. All right. In the same manner that we used the third equation to find the measure of angle C, this time to find the measure of angle A, we're going to use the first equation. All right, so let's copy that down here. Or to find the measure of angle A, we use b squared plus c squared, and take away the product of b, c, and cosine A. All right, now let's actually enter the information that we have, where A is 6.3, B is, A is not 6.3. Instead, A is actually 10.5, all right, 10.5 squared, which is equal to 6.3 squared plus 12 squared minus, and then we're plugging everything in that we have right now, okay? So 12, and then of course cosine A, which we are trying to identify the measure of angle A. And in the same manner, you want to isolate cosine A so that we can solve for the angle measure. And to do that, we need to move a few things over. Let me relocate 6.3 squared and 12 squared, and then leave the remaining values with cosine A. Okay, So the main reason we're not able to also relocate these three terms being multiplied by cosine A is because they're being multiplied. So you can't just subtract it. Instead, you'll have to divide it. Okay, that's the more reasonable step. Okay, otherwise you're violating the rules. It doesn't follow a specific structure. So if we try and do this, we can simplify the left-hand side. All right, so let's see. Go ahead and look for the difference of those squares you were given. And you should have gotten negative 73.44. Again, this is an exact value. And on the other side, when you multiply the other three values, you should have gotten negative 151.2, still being multiplied by cosine of A. And so from this step, similar to what we did with cosine of C right here, we need to isolate the given by dividing by 151.2 negative. All right, and in the same manner, so to find cosine A, all right, we need to divide negative 73.44 over negative 151.2. All right, I'm sort of running out of space, so let's see if I can continue to fit this in. But remembering that we're actually solving for an angle measure. So that means we need to find and use the inverse function. To find the measure of angle A, we need to use the inverse of negative 73.44 over negative 151 point. I did not write it here. All right, 0.2. Okay, so go ahead and evaluate this into your calculator and see if we result in the same angle measure. All right, so in this case, let's see, making sure that you're in the right setting, you're in the right mode, okay, and then closing the parentheses as you go forward so that you don't get any syntax errors over there. All right, so I'm finding it's about 60.94, all right, or close to. So because it is super duper close, we're going to say that it is about 61 degrees, right? Okay, let's see. 60.9. Yeah, no, 60.9 degrees. Okay, so it's at this point that some of your answers will vary. So some of you may have started by identifying the measure of angle B instead. And if you did that, if you look for angle B first, then our value will be a little bit different, just a slight bit off, just because the values that you followed were a little bit different. So at this point, we've also found angle B, okay, and I'll explain that further in a second. Now to find the measure of angle A, okay, the last angle, you take away the other two that you have found, okay, so minus 60.9 degrees as well. Okay, so I think we're going to be able to say that the measure of angle A would be just about 31.7 degrees. Okay, all right, right here. All right, so now you've actually found all the three unknown parts, which means you've solved the triangle. So the only concern I was mentioning is that if you found angle B first, you can try this out. If you found angle B first, what would have resulted would have been a measure of 30. Angle B would have been your 31.6 degrees instead of angle. Angle B would have been 31.6 instead. I'm sorry, this was supposed to be for angle B. It would have been 31.6 instead of 31.7 because then the measure for angle A will be at 61 degrees. So it's a slight bit different depending on which one you solve first. As long as I see that it's not 1 degree off completely or 2 degrees off, then I know that you only rounded towards the end or at the very end of your equation. Okay? All right. So on the next page, you're going to have an opportunity to work on the following. All right, so whenever you're ready, feel free to go ahead and continue the video. And for now, you can pause it and give yourself time to answer the following. Alright, so you start by listing down the missing measurements. In this case, you need to find the measure of angle B. You also need to find the measure of angle C and of course side A. In order to do that, you want to make sure you know what information you have. You have two side lengths and an angle measure. So not drawn to scale. It may look something close to this, okay, something like this, where this is the obtuse angle 173A, alright, like so. And then I can set this angle here as B and C here. So all we know is that side B is 23, side C is 18, okay? Alright, so give yourself a visual, especially if that's something you prefer. So because we have the three information, side, angle, side, as we did previously, you want to start by finding the third side. Okay, why the third side? Again, because you already have two side lengths and you just need one final side, and that will, side A, that will allow you to complete at least half of the unknown values. Okay, all right. So let's go ahead and do that. In order to do that, you use the law of cosines. Okay, so essentially you're plugging in all the information you have. Okay, so let me write this out. Cosine of A. And when you do that, we have the unknown. We have side B, which is 23 plus 18 squared minus the product of the other values. Especially with the part with the B times C. It doesn't really matter if the C comes first, since you're multiplying them all together. Okay, the cosine of 173 degrees. And in doing this whole process, you will end up with a given value. It will be about 1674.83, just about. But remembering that you need to find the square root. I don't need a squared, right? We're looking for a length A. So you do need to find the square root. And of course, we take the positive length, which is 40.9. Okay, that means we found the third side. Now we're ready to find the other two unknown values, the two unknown angles. So it doesn't matter which angle you find first. Okay, in this case, I'm going to go ahead and find the measure of angle B. And in order to do that, I need to use the law of sines. So let me go ahead and create sine B. I don't know what it is, over the B side, which is 23, and setting it equal to the other known value, side A and angle A, like so. And then you'll go ahead and proceed and do your cross multiplication. And once you have that, you know that you'll have to find the inverse sine to find an angle measure. Okay, so let me go ahead and go forward with this. To find the measure of angle B, we need to use the inverse function for sine. All right, we're going to plug in the information you have. Okay, and yes, I am skipping a few steps because at this point, you should be able to cross multiply and isolate sine B. If you need further assistance with that, please refer to the previous example in this video. And once we've evaluated the given, the measure of angle B, when rounded to the nearest tenth, will give you a 3.9 degree measure. So at this point, we found side A and angle B. And of course, to find the last angle measure, angle C, we take away the other two angle measures that we know and subtract it from 180 degrees. And the measure for angle C will be at 3.1 degrees, like so. Alright, so now we've found all the three unknown values in problem 1A. Let's go ahead and proceed to problem 1B. Right now you know that there are three side lengths that you were given. So let's draw it out right here. Again, not drawn to scale. You can decide what goes where, making sure that the sides are corresponding to the angles that you're writing down, like so. And of course, this time, because you have three side lengths, the very first thing you always want to do, okay, is to find the largest angle measure. Okay, the largest angle measure. In this case, that will be the angle for C. Okay, see how angle C is right across 50.3. So let's write it down. The measure for angle C. That's what we're trying to find. And we can start by, of course, using the law of cosines. Because we're looking for the measure of angle C, we will use the equation where we're going to isolate cosine C. Okay, all right. Again, of course, later on we have to use the inverse function in order to identify that angle measure. All right, so let's go ahead and plug in the information we have. 50.3 squared, and then 35 squared plus 42 squared right there. And then we're going to go ahead and multiply these two values together with 2. And of course, cosine C, which later on we'll be looking for the inverse function. All right, so let's go ahead and move all the other terms to the other side. Take away 35 squared and 42 squared, and then leaving the remaining on the right side with cosine C. Okay, all right, so let's go ahead and simplify these values that we have for now. So if I were to simplify the left-hand side, I should end up getting negative 458.91, an exact value. On the other side, on the right side, when I multiplied these together, let's see what we found. Negative 2 multiplied by 35 and 42 is negative 2940. Okay, so let's write it down. Again, still being multiplied by cosine C. Okay, all right, and because we're trying to solve and isolate for cosine C, let's divide this by 2940, 2940 negative. All right, but remembering, because we're looking for an inverse function, to find the measure of angle C, you need to use the inverse cosine function and enter the following in your calculator to help you evaluate 2940 down here. And once you do that, I'm hoping that you found the measure for angle C to be 81 degrees when rounded to the nearest tenth. All right, so we found the largest angle measure. And if you want to give yourself more structure, I know I said it doesn't matter which angle you find next, but if you want to give yourself more structure, since we started with the largest angle measure, you can go ahead and find the next value, which will be less than the largest angle, so the middle value. In this case, because the middle value is at 42 and it's right across angle B, what I mean by middle value is, of course, you have the largest, the middle, and the smallest angle length, right, or value. So we're going to look for angle B right now. Okay, to find the measure of angle B, we need to use another law of cosine. And so we're going to be using b squared equal to a squared. Okay, so this time we're going to use where you're looking for cosine B, or the inverse of cosine B. All right, sorry, that's supposed to be a C. Taking away 2ac times the cosine of B, like we said. And once you've plugged everything in, okay, I'm going to go ahead and do this right here. I'm going to show you the values that we found. Once we've isolated, the left-hand side should have said negative 1991.1, or 09, sorry, that's an exact value. And then on the right-hand side, we were supposed to get negative 2 multiplied by 35 multiplied by 50.3, which is negative 3521, still with a cosine B, right? So we're still multiplying. And so to find the cosine B value, you must divide negative 1991.09 over negative 3521. Okay? Or in other words, to find the measure of angle B, we need the inverse cosine of negative 1991.09 and divide it by negative 3521, like so. And when you do, angle B rounded to the nearest tenth would be a 55.6 degree measure. Okay, so we were trying to give ourselves more structure in solving so you know what to do next. We started out finding the largest angle measure, C, based on the side lengths, okay? And then we proceeded to find the next angle measure, angle B, which is less than the largest one, so that now we've found two of the unknown values, angles C and B, and now we're down to our last angle, the smallest angle measure, angle A, okay? In order to do that, to find the measure of angle A, again, we take it away, or we take away the two angle measures, 81 and 55.6 degrees. And so angle A rounded to the nearest tenth will be a 43.4 degree measurement. Okay, all right, so hopefully we're addressing questions you may have or items that are coming up. I know I'm skipping a couple of steps down here. If you need help with that, please make sure you refer to the previous page. All right. All right, so in addition, the law of cosines can also be used to derive the formula to find the area of a triangle based on just the side lengths. So this formula is called the Herons Formula. Okay, so I know you remember, okay, wait, we just did something similar when we were working on the law of sines, right? We used the law of sines, or the function sine, to find an area measure. However, you were only able to use it if and when you were given two sides and an included angle. All right, but right now what I'm going to be sharing with you is another formula to find the area if and when you're only given three side lengths. Okay, so according to Heron's formula, okay, for a triangle ABC, where S is the half of the perimeter, or half of the perimeter, you can use the formula right here. Okay, but first you need to identify side S, or S, which is half of the perimeter. And you know, to find the perimeter, you add up all the sides. Okay, I'm sorry, that's not right. Let's redo this part. Okay, to find the perimeter, you add up all the sides like so. However, because you're looking for half of the perimeter, S, you must divide that sum by 2. Okay, the reason we're doing this is because we need to use that information, half of the perimeter, and plug it in for the formula. All right, so let's try it out with this example below. A blueprint shows a reception area. Pretty cool, I guess, for a reception to be triangular, something different. And it has a triangular floor whose side lengths measure the following: 22, 30, and 34 feet, respectively. What is the area of the floor to the nearest square foot? So we're going to round our answer again towards the end. So let's go ahead and start by identifying S. We need that value, half of the perimeter. So let's go ahead and add all our sides together. Okay, get the sum and then divide it by 2. So S here in this example would be 43. Okay, so how are we going to now use S, 43? We're going to go ahead and plug it in to find the actual area. So let's go ahead and work on finding the area given 3 side lengths. All right, where S is 43, I'm going to go ahead and plug it in, 43. And at this point, it doesn't matter which one will be A, B, or C, since you're subtracting them from 43 anyway. And again, it doesn't matter which value you write first, since you're multiplying them all together and getting their square root. Okay, please make sure you get the square root. If you don't, that's not the area yet. And once you find the square root and round to the nearest tenth, or sorry, in this case, nearest square foot, it will be at 367 square meters. All right, so just by using the side lengths and finding half of the perimeter, you're able to tell the area of a given triangle. Okay, so on the next page, you'll have an opportunity to try this out. Feel free to pause the video at any point. All right, so go ahead and pause the video right now and give yourself a chance to practice. The surface of a hotel swimming pool is shaped like a triangle, very, very modern, with side lengths measuring 50, 28, and 30 meters. What is the area of the pool's surface to the nearest square meter? So considering, again, you only have 3 sides, you really want to use the formula, Heron's Formula. Okay, so first you start by identifying S, half of the perimeter, like what we did previously. And let's take a look at that. So half of the perimeter, so I tried to illustrate it just as a visual. Again, not drawn to scale, obviously, and not accurate as it should be, but just as a visual. So let's find S. All right, S will be when we add all the side lengths divided by 2, which is 54 in this case. And we'll go ahead and plug it in. So it doesn't matter which value you key in first, whether it's 54 minus 30 or 54 minus 28, since you're multiplying those values together. However, please make sure that you're getting the square root, again, to find the area. So in this case, I am hoping that we are finding the same area measure, which is 367 square meters. All right. In the past, I think we made a typo. Let me go ahead and fix that. It is not 367. Thank you for pointing that out. It is actually 325 square feet. Okay, so my values are correct, but the final answer we left it with was not. So let's go ahead and address that. Thank you for pointing that out. All right, so now that we fixed that, going back to the last problem. Okay, so the area for the given triangle or the given pool will be at 367 square meters. And this is how you can continue using the law of cosines. They're not completely independent from each other. There may be times that you'll have to use them together, like what you've seen previously, where you had to apply the law of sines to find angle measures as well. Okay, and it's really helpful to know when you're using each of them, when they're going to be useful to you. When do we use the law of cosines? When do we use the law of sines, right? It depends on what information you're given, whether you're given angles or side measurements. So you'll have to check those out. That will be a very helpful tip to watch out. So write them down, okay? So I'll end here. I'll see you really soon, okay? Bye for now.